At the end of the fifth report period, flight worthiness tests were complete, and the flight test program plan was on schedule. Behind approximately 1 month were power plant manufacture, wind tunnel flutter tests, aircraft design and fabrication, and the flight simulator program. The ejection seat program was about 3½ months behind. Flight worthiness tests were conducted in the outdoor test stand in Evendale, Ohio. Operation was in accordance with contract specifications to form the basis for a flight worthiness rating for the propulsion system and to ensure that it has sufficient durability and reliability to permit experimental flight tests. The installed system included 2 J85 GE5 turbojet engines without afterburners, 2 X-353-5B diverter valves, 1 X-353-5 lift fan, and 1 X-376 pitch trim control fan. Thermocouples were attached to the protective screens to measure temperature in the low-velocity flow fields. Screen flow losses reduced lift by less than 0.4%. To simulate a complete flight cycle, the first test included ground start of engines, fan-powered vertical flight, transition to cruise mode, cruise, transition to hover, and vertical landing. Testing began on November 21st, 1962. The J85 was brought to 40% speed and checked for normal operation.
Ignition off. We're at idle.
Number 2 was started. With both engines running at about half speed, the diverter valves were actuated to deliver power to the fans to simulate vertical takeoff. Fans came up to speed. Pitch fan doors were positioned for takeoff. Inline readouts indicated variation in pitch and wing fan RPM, balancing system thrusts. Power was increased for liftoff. Test frame load cells indicated reduced downward forces as fans exert lift. Fan speed increased to gain transition altitude. The Sanborn recorder on the right provided a permanent record of speed, temperature, and vibration. The digital computer, left, supplied a continuous temperature printout.
We're going to make a change on our loser.
Transition altitude.
1 to -19 degrees.
Wing fan exit louvers were controlled by a series of beep switches vectoring thrust to the rear. Horizontal thrust builds. Stress measurements were displayed on this oscilloscope bank. Critical readings were visually monitored, and all data were recorded for later reduction and analysis. The fans were now supplying enough forward speed for wing-supported flight. Diverter valves were switched to straight-through flow position. All fan doors and louvers were closed, and the system was in forward flight condition. With the cruise run complete, transition back to fan-powered flight began.
With both engines.
The fans began to spin. Aerodynamic pressures in the fans, J85s, and valves were monitored and periodically photographed on this manometer bank. With the system in hover condition, throttles were retarded for the vertical landing. The first flightworthiness test run was over. Results of these tests showed that the lift fan system meets or exceeds all major requirements. The propulsion system was disassembled and arranged for preliminary inspection. Only minor discrepancies were found in some external components. Pending the results of the detailed teardown and inspection, the second set of fans will be acceptance tested and installed in the XV-5A for flight test. Representatives from USA TRICOM and the Federal Aviation Agency, along with General Electric project personnel, inspected system components. Acceptance running of flight test fans is now underway. The milling of wing structural members was part of the progress in airplane manufacture at Ryan. Here, the main carry-through of the fuselage to wing attachment is shaped to conform with a contour pattern. Rough cutting of the forward wing spar aluminum billet prior to final shaping. The wing fan door will form the upper surface of the airfoil during turbojet flight mode. Doors have undergone a design change to increase stiffness as a result of static test. Hinge attachments are fastened directly to the surface of the fiberglass honeycomb door. A form die was made as a pattern for the aft fuselage and vertical stabilizer section. Plaster form dies are an intermediate step in the fabrication of the outboard wing panels. The forward fuselage integral fuel tank will be slosh tested before installation in number 2 airplane. Formers define the contour of the aft fuselage section of the number 1 airplane. The main fuel cell bulkhead and the main assembly jig. Aft upper fuselage with the vertical stabilizer in the foreground. The vertical stabilizer, aft fuselage bulkhead. Aluminum skin being fitted and riveted. Simulation of conventional flight has been completed. Characteristics in minimum to maximum speed range were satisfactory. Airplane hydraulic and electrical components are being installed on the simulator. In January, the Federal Aviation Agency reviewed the XV-5A program status and objectives. Conventional flight and fan-powered flight scale models were displayed with the full-scale engineering mock-up. USA TRICOM and General Electric project heads discussed cockpit arrangement. With good progress in manufacture and testing of the propulsion system and airframe fabrication, major program milestones are being achieved.